So hello everyone. So today we will be covering another complex topic from unit 2, which is circuit realization using multiplexer and decoder. So these are the contents. So first we will be covering the basic concept of multiplexer, then how that concept can be used to realize various combination circuits. Similarly, then we will proceed to decoder, its basic concept, and how this concept can be used to realize various circuits. So let's start with the basics of multiplexer. So multiplexer, it is a combination circuit. Okay, it has multiple inputs and only one output. So multiple inputs, they can be 2 raised to power n. That means where n is the number of select lines. So if these are the n select lines, for these number of inputs can be 2 raised to power n, and these inputs are labeled as I0, I1, I2, I3 and I2 raised to power n minus 1. Okay, so if we put n is equal to 2, let's suppose we put this n is equal to 2, that means there are 2 select lines. So in that case the multiplexer will be for 2 select lines. Let's say we name them as S1, S0, and there will be 4 inputs. The input names will be I0, I1, I2 and I3. Multiplexer name is 4 cross 1 because there are 4 inputs and single output Y. Similarly, if I put S is equal to 1 or n is equal to 1, that means a multiplexer with a single select line. So this is this 2 cross 1 multiplexer. So for a single select line, inputs can be 2, I0 and I1. So 2 inputs are there and single output is there. So the name 2 cross 1. And the operation can be understood as we have to apply some value on the select line, and based on the value we apply at the select line, one of the input will be selected and that selected input will be connected to the output. So if I put S naught is equal to 0, that means if I place a 0 here, then out of these 2 inputs, if I label these inputs as 0 and 1, so this I naught will be selected and connected to the output. If I place S naught is equal to 0, similarly if I place S naught is equal to 1, then this I1 will be connected to Y. Okay. So if I want to write the expression for this truth table, then I can write that Y is equal to 0 for 0, that means S naught bar into I naught plus this S naught into I1. Okay. So this is the expression and we can make a circuit for the same, but the main thing is we are not covering the topic basic of multiplexer. We are mainly focusing on how this multiplexer can be used to realize various combination circuits. So we can make a circuit for this one, but if we are interested in, similarly we can proceed for the 4 cross 1 multiplexer in which there are 2 select lines, 4 inputs are there which can be labeled as 0, 1, 2 and 3. If you place 0, 0 on the select line, then this I0 will be selected. If you place 0, 1 on the select line, I1 will be selected. If you place 1, 0 on the select line, I2 will be selected. If you place 1, 1 on the select lines, I3 will be selected. And in all those 4 cases, every time an input is selected, that selected input will be connected to the output. That's why in this truth table, we are seeing that for that particular case, Y is equal to I0, I1, I2 and I3 for the 4 cases in which we are putting different values of the select lines. So this is, so we can write expression for that as well. S1 bar S0 bar into I0, this was written here. Similarly, S1 bar S0 into I1, S1 bar S0 into I1, S1 S0 bar into I2, S1 S0 bar I2, and last one S1 S0 I3, S1 S0 I3, and we can make a circuit for that. That will be the internal structure of the 4 cross 1 multiplexer. So this is the basic of multiplexer, and now we can proceed towards the circuit realization using multiplexer. So designing MUX base, MUX is a short form for the multiplexer. So design a multiplexer based circuit for the following expression FABC is equal to summation M 1 2 3 6 7. So first of all, we will be very much comfortable in reading those expressions, that how many variables are there. So we can see from this expression that there are 3 variables A, B and C. So for 3 variable input, for 3 inputs or 3 input variables, this problem has to be directly related with a multiplexer which has equal number of select lines, so that those inputs can take place of the select lines. So these are the inputs A, B, C. So I have to choose that multiplexer which has 3 select lines. So if select lines are 3, then inputs will be 2 raised to power 3, that means 8. So and output is always 1. So the multiplexer which we are going to use is 8 cross 1 multiplexer. So this is an 8 cross 1 multiplexer. We have selected 8 cross 1 multiplexer, and simply which would we generally write S2 S1 S0. So in place of S2 S1 S0, we will be using A, B and C. Okay, and inputs for these 3 select lines, the inputs will be 0 1 2 3 4 5 6 and 7, and there is a single output Y. So the very simple thing, okay, to start with, we have to choose a multiplexer size in which the number of select lines is equal to number of variables. So variables were 3. So we have chosen select lines multiplexer with select line equal to 3. That means we have chosen 8 cross 1 multiplexer. So now we are very much clear that 8 cross 1 multiplexer, it will be having 8 inputs, and out of those 8 inputs, we have to put 1 and zeros on these 8 inputs depending on the question provided to us. So the question says that the variables, for 3 variables A, B, C, the function is such that it produces high output. High output, because why I am saying high output? Because these are minterms. Minterms means output with high value, that means output is equal to 1. So these are the 5 locations. Which are the 5 locations? 1, 2, 3, 6 and 7. These are the 5 locations in the truth table of this 3 variable problem where output will be high. So if I am going to realize this problem using a multiplexer, then I have to simply use 1, 2, 3, 6, 9. That means I have to separate out these 1, 2, 3, 6 and 7. So once I have separated them out, then I have to connect them together and connect it to logic 1, because at these 5 locations I am expecting my output to be high. So whenever out of these 5 inputs will be selected by this multiplexer, output will be high. Okay, and the rest of the inputs which are not mentioned in the problem or the question, these are the min terms. So definitely the remaining terms will be the max terms. So max terms will be 0, 4 and 5. So I will be connecting together 0, 4 and 5. So this is 4, this is 5 and this is 0. These 3 things are going to be connected with logic 0, so that whenever any value is placed on these select lines A, B, C, and if they select 0, 4 or 5, output will be 0. Okay. So in this way we can realize any expression using a multiplexer. We just need to have the min terms. So if we are provided with an expression, we can convert that expression into min terms, and those min terms can be connected to logic 1, and the remaining terms, which can be referred as max terms, can be connected to logic 0. So now examiner might tinker the question a bit and say, realize a problem which is having 4 variables. 4 variables A, B, C and D. Okay, so for these 4 variables A, B, C and D, it would have been very much convenient for me to realize this expression using a 16 cross 1 multiplexer, because that 16 cross 1 multiplexer would be having 4 select lines. So 4 select lines can easily be replaced with the 4 variables A, B, C and D, but examiner has mentioned that you have to perform, you have to realize this circuit, you have to realize this 4 variable problem using 8 cross 1 multiplexer. That means the size of multiplexer is smaller than the number of, is lesser than the number of variables given in the problem. So definitely, if my variables have to take place of the select line, then there are only 3 places that can be taken. Either I can use ABC as the select line, or I can use BCD as the select line. Okay, so I have to drop one of the variables which are going to be used at the select line. So if I decide that I will not be using A, that means A is not going to be used and B, C, D are going to be used as select lines. So I have decided that I will be using B, C and D as select lines. So I am not going to use A at the select line side. So that means I have eliminated A. Okay, so we can perform it like this: A is equal to 0 and A is equal to 1, and B, C, D are going to be used for operating the multiplexer. That means having different values, that means 0, 0, 0, 0, 0, 1, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 111. So these are the 8 possible values which can be applied at these select lines, and if I do that, then correspondingly some inputs will be selected as a normal 8 cross 1 multiplexer would do the purpose. So if I place 0, 0, 0, BCD is equal to 0, 0, 0, then what will be selected? I0. If it is 0, 0, 1, then I1. If it is 0, 1, 0, then I2. Similarly, I3, I4, I5, I6 and I7. And the thing which we have to remember is that we are not going to use A. Okay. So we are going to label these cells, and we should not be forgetting that A is my MSB. Okay. So the flow of counting will be from A to D. Okay. So if I read the value of A first and then BCD, so A is 0, BCD is 0. So 0, 0, 0, that means this cell can be labeled as 0. Similarly 0, 0, 0, 1, it will be 1. 0, 0, 1, 0, it will be 2. 0, 0, 1, 1, 3. 0, 1, 0, 0, 4, 5, 6, 7. Similarly 1, 0, 0 is 8. Similarly proceeding further 10, 11, 12, 13, 14 and 15. Okay. So we have labeled these cells. Now we have to feed the terms which are provided in the question, so that you can notice one thing. I have not read the question's main terms. I have just read from the question that there are 4 variables, and the MUX which I am provided is 8 cross 1 multiplexer which is having 3 select lines. So that means one of the input has to be eliminated, and based on that I have made this arrangement, and I have not even looked at the question which are the minterms. Now is the time that I will be looking at those minterms, and I will be feeding those minterms in this prepared layout. Okay. So the minterms are 1, 2, 6, 7, 8. So 1, 2, 6, 7, 8, 12, 14, 15, 12, 14 and 15. Okay. So this is the arrangement. Now we can see that in this first column, when I place BCD is equal to 0, 0, 0, I0 will be selected and it will be connected to, if there would have been 2 1s here, then it wouldn't have mattered what is the value of A. In that case, I can say that I0 will be connected to 1, whatever is the value of either it is. If it is A is equal to 0, then also it will be connected to 1. If it is 1, then also it will be connected to 1, but it is not the case here. As we can see, under this I naught column there is a single 1. So for this single one, this corresponds to A naught, A is equal to 1. That means it corresponds to A. That means if 1 means A and 0 means A bar. Okay. Similarly, if we check I1 column, there is a single one which corresponds to A naught is equal to 1. Okay. That means it will be connected to A bar. Similarly, again single one corresponding to A naught, A is equal to 0, that means again A bar. Then there is no 1 under I3 column. That means it is neither going to be connected with A naught, A is equal to 0, or A is equal to 1. That means it is going to be connected with 0. Similarly, I4 you can check, there is a single one which corresponds to A. There is no entry here, that means 0. Both entries are 1. That means whatever the value of A is, either it is A is equal to 0 or A is equal to 1, in any of these cases the connection will be permanently 1. Similarly is the case for this I7. Okay. So I have now 4 possible connections, 0, 1, A and A bar. Okay. So I will be making those connections now. So there are A at 2 places which are 0 and 4. So 0 and 4. So I am connecting it, 0 and 4 are connected to A. Similarly, A bar is to be connected with here, I1 and I2. So if I place a NOT gate here, and connect it to I1 and I2. Okay. Now there are zeros at 2 places corresponding to this 3 and 5. That means I3 and I5. These I3 and I5. These are going to be connected with 0. Similarly, you can check that there are 2 ones, these two, corresponding to I6 and I7. That means these I6 and I7 are going to be connected with logic 1. Okay. So this is the arrangement, and this will be my output. F is a function of A, B, C, D. Okay. So in this way we can eliminate one of the inputs and proceed with the multiplexer realization using a smaller size MUX as well. Okay. So in this way we can realize expressions using multiplexer. Similarly, you can take any other question as well. You can take an expression F is equal to A bar B plus B bar C, and you have to realize this using 8 cross 1 or 4 cross 1. So A bar B, first of all you have to convert this into canonical form, then it will be this. Okay. Then it has to be A bar B C plus A bar B C bar. Here it will be A B bar C plus A bar B bar C. Okay. So replacing bar with 0 and non bar with 1. So we can check that this is 1, this is 5, this is 2, and this is 3. So the question becomes, this is a function of 3 variables A, B and C, which is having the main terms 1, 2, 3 and 5. Okay. So if this question has to be realized using 8 cross 1 multiplexer having 3 select lines, I have to simply replace those 3 select lines with A, B and C. Simple. Okay. But if the same question is to be done with using 4 cross 1 multiplexer, that means it will be having 2 select lines. So in that case, these 2 select lines I will use B and C and A will be eliminated, as we have done in our previous question. And similarly, we can proceed further with the circuit realization. Okay. So this is how we can realize expressions using multiplexer. So now coming to decoder. Decoder, like multiplexer, it is also a combination circuit and is a special case of demultiplexer. Why it is called a special case? Because a demultiplexer has a select line, but a decoder doesn't have select lines, and actually those select lines become the input. Okay. And for n inputs, maximum number of outputs can be 2 raised to power n. So if we take example of a demultiplexer, let's suppose I take example of 1 cross 4 demultiplexer, which is having 4 outputs, 2 select lines S1, S0, and there is a single input I. So how this demultiplexer is getting converted to a decoder? So I am saying that it does not have select line. Actually select lines becomes the input. Okay. So these select lines are placed at the input side. So this S1, S0 are placed at the input side, and these are being referred as I1, I0 instead of S1, S0. Okay. And the outputs are 4. So 4 outputs are there: 0, 1, 2, 3, Y0, Y1, Y2 and Y3. The only difference is that actual input I is not there. That means whatever output is selected, that selected output will not be connected to I, because I is not there. In case of demultiplexer, the selected output is connected to I, but in case of a decoder, the selected output will be connected to 1 instead of I. So if I place 0, 0 on the input side, then Y0 will be selected and it will be connected to 1. Similarly, if I place 0, 1 at the select line, Y1 will be selected and it will be connected to 1. Similarly, if I place 1, 0, then Y2 will be selected, it will be connected to 1. Similarly, if I place 1, 1, then Y3 will be selected and it will be connected to 1. So for all these 4 expressions, Y3, there is a single one which corresponds to I1 is equal to 1 and I0 is equal to 1. So Y3 expression is I1 into I0. Similarly, Y2 is giving 1 here. I1 is equal to 1 and I0 is equal to 0. So I1 dot I0 bar. Similarly, Y1 here, I1 bar I0 and Y0 both are 0. That means I1 bar I0 bar. And similarly, we can proceed with the circuit realization using circuit realization for this decoder. Simply we can draw the circuit. But once again, the topic is not that we are here to understand we have understood the basic of decoder, but the aim is not to realize the internal circuit of decoder. The topic actually which we are covering here is how to use this decoder as to realize any circuit which can be designed using the basic logic gates. Okay. So this is the basic of decoder, how input is selecting one of the output and that output is getting connected to high logic. Okay. So if we are going to proceed for circuit realization, and before circuit realization, design a decoder based circuit for the following expression. So in this, there are no such constraints which were available with the multiplexer, that it can be multiplexer is having only one output. Okay. So there is a problem with multiplexer, that if my system or the problem which I am going to design is having more than one output, then a single multiplexer cannot solve the purpose. In that case, I have to use that many multiplexers, that many outputs I am requiring in my system. Okay. So designing a decoder based circuit for the following expression, FABC is equal to 1, 2, 3, 6, 7. So number of inputs are 3 or number of variables are 3. That means I will be choosing a decoder which is having 3 inputs. So what will be the decoder with the 3 inputs? Or simply you can relate it with the last multiplexer based realization. We have related those inputs with the select lines, and for those select lines there were 2 raised to power n inputs. Similarly here, for 3 inputs, the outputs will be 2 raised to power 3. That means the decoder which we are going to select is a 3 cross 8 decoder. Okay, 3 cross 8 decoder. The inputs will be instead of I2, I1, I0, inputs will be A, B and C. There will be 8 outputs, 0, 1, 2, 3, 4, 5, 6 and 7. Okay. So, this expressions actually means that this is an SOP expression which will be having these 5 high values. That means output is high at these 5 locations, or we can refer them as the canonical terms. If I refer them as canonical terms, then this 1 will be equivalent to 0, 0, 1 and 2 will be equivalent to 0, 1, 0, 3 will be equivalent to 0, 1, 1, which and further 6 similarly 6 will be equivalent to 1, 1, 0, 7 will be equivalent to 1, 1, 1, which will be ultimately equivalent to A bar, B bar, C, A bar, B, C bar. Similarly this one A bar, B, C. For 6 it will be A, B, C complement. Here it will be A, B, C. Okay. So if I connect those, if I make connection according to that, then I am very much clear that similar kind of expressions decoder is already giving me. But this summation means SOP. That means all those products are going to be added together. Okay. So these 5 canonical products are going to be added together. And need not to say that these 1, 2, 3, 6, 7, this is 1, this is 2, this is 3, this is 6 and this is 7. So these 5 main terms are corresponding to these 5 products which are already available at the decoder's output. Okay. And I just need this plus term. That means I need to perform OR. I need to perform OR of these things. That means all these 5 terms are to be simply added. That means this will produce the function FABC. Okay. So in this way, any expression can be realized using decoder using the simple concept that if the number of inputs in the problem to be realized is equal to the number of inputs in the decoder, then this can be done very much easily. I just need an extra OR gate depending on the size of OR gate. Size of OR gate means the number of inputs in the OR gate will be according to the minterms provided in the question. If there are 5 inputs, 5 minterms are there, that means I need to prepare an SOP expression which will be having 5 products. That means 5 things are to be added, so 5 input OR gate is required. Similarly, another problem might be requiring lesser or greater number of inputs, and depending on that I will be choosing the size of the OR gate. Okay. So design a full adder using decoder. Now this is an interesting problem. That means if I can realize a full adder, that means I can realize anything using a decoder. So for that I should be having the truth table of a full adder which is having 3 inputs A, B, C, and there are 2 outputs, sum and carry out. So the 3 inputs are 000, 001, 010, 011. These are the possibilities 100, 101, 110 and 111. And if we add them, 000, sum is 0, carry is 0, sum is 1, carry is 0, sum is 1, carry is 0, sum is 0, carry is 1, sum is 1, carry is 0, sum is 0, carry is 1, sum is 0, carry is 1, last case 111, sum is 1, carry is also 1. So I can find that sum is equal to, main terms are 1, 2, 4 and 7, and for C out carry, the main terms are 3, 5, 6 and 7. But the thing is, in this case my circuit is demanding 2 outputs. In case of a multiplexer, in case of a multiplexer, the output can be a single one, but in case of a decoder, the output can be any number of output can be done. So we have to choose a decoder with inputs equal to number of variables. That means I will be again choosing a decoder with 3 inputs, A, B and C, 3 cross 8 decoder, 0, 1, 2, 3, 4, 5, 6, 7. So these are the outputs. Okay. And 1, 2, 4, 7. This 1, this is 2, this is 4 and this is 7. So these 4 things will be added to generate sum, and similarly 3, 5, 6, 7. This is 3, this is 5, this is 6 and this is 7. So these 4 things will be added to generate C out. Okay. So the benefit of circuit realization using decoder is that my system can have any number of outputs, and that multiple outputs can also be realized using a single decoder. But if you want to realize the same full adder using a multiplexer, then for some output we will be requiring a separate multiplexer, and for carry output we will be requiring a separate multiplexer. So with this we come to the end of today's lecture. Thank you very much.